Hello everyone, welcome back to Hidden in the Stars. This week we're covering an interesting question that everyone has wondered once in their lifetime. What is the universe made of? The universe is made up of building blocks called matter. Matter is defined by NASA as any substance that has mass and occupies space. There are different types of matter: antimatter, strange matter, exotic matter, all sorts. There are 5 main fundamental states of matter. While most people are familiar with the first 4, solid, liquid, gas, plasma, there's a little-known 5th one called the Bose-Einstein condensate, which is created in laboratories. The universe is made up of mysterious substances that affect its shape. It's 27% dark matter, 5% visible matter, and 68% dark energy. Normal matter is known as baryonic matter. Normal matter is all the atoms that make up everything we can interact with. It's composed of baryons. Baryons are subatomic particles that are composite and have a mass equal to or greater than a proton. Examples would be protons, neutrons, L-baryons, which are composed of 1 up, 1 down, and 1 strange quark, and other particles made up of 3 quarks. They are fermions, which means they have a 1/2 integer spin. They also participate in the nuclear force, which is a strong interaction, not a weak one. Dark matter is unique. Much like ordinary matter, it can hold mass, but it doesn't reflect, radiate, or absorb light. At least, not enough for us to detect yet. Scientists aren't exactly sure what dark matter is. So far, the theories include a few different types of unidentified particles. It can take the shape of several forms, including randomly moving particles, which were created soon after the Big Bang, or weakly interacting particles unlike baryonic matter. Examples may be WIMPs, weakly interacting massive particles, and MACHOs, massive compact halo objects. MACHOs can be things like white dwarfs, faint stars, neutron stars, black holes, or non-luminous objects like planets. WIMPs, according to Britannica, are heavy, electromagnetically neutral subatomic particles that are hypothesized to make up most dark matter. They're estimated to make up somewhere around 22% of the universe. Remember, this is all hypothesized. Dark matter is quite a mystery. Dark energy is very, very important. However, scientists know less about dark energy than they do dark matter, even though it makes up roughly 68% of our universe. It must exist to explain the accelerating expansion of the universe. Accelerating expansion of the universe? That seems a bit controversial. I've heard that the universe is slowing down. Well, in the late 1920s, astronomers discovered that the universe is actually expanding. In the 1990s, supernovae were studied, and the data and discrepancies in the data showed that the universe used to expand more slowly in the past. Well, except for the initial start of the universe, which expanded ridiculously fast. Why? We're not quite sure, but the leading explanation is that the universe contains something that has a repulsive gravitational effect. This means that the universe is being pulled further apart, which is expansion. Now that we know the main types of matter and energy in the universe, what are some of the other types of matter? What is the cosmological constant? What does cosmological constant even mean? Slow down there, you speedy comet. I'm getting there. The cosmological constant, in simple terms, is considered the leading theory for dark energy. It may be the cause of acceleration of the expansion of the universe. According to Scholarpedia, it's a homogeneous energy density that causes the expansion of the universe to accelerate. Soon we'll go over another episode on what it means when astronomers say that the universe is homogeneous and isotropic. We are not at the center of the universe, not because the universe has no known center. Okay, we covered the cosmological constant, which is represented by the Greek letter lambda. Oh yeah, it's a term in Einstein's equations of general relativity. Yet another fun episode, Newton versus Einstein and their takes on relativity. You're probably dying to know, what are the other types of matter? Well, there's too many to list here. With a better understanding of quarks and gluons, leptons and photons, we'll be able to cover more types of matter in other episodes. But for now, let's not forget my favorite, strange matter. Strange matter is hypothetical. It's a form of quark matter theorized to be composed of strange quarks. It's theorized to potentially eat ordinary matter under specific conditions. This would create more strange matter. It's thought that neutron stars are the most likely place to find it in the whole universe. From strange to exotic matter, astronomers and astrophysicists are still discovering the world around us every day. The very fabric of space-time can be a mystery. Will you help us solve it? For all budding scientists, take our planetary quizzes and see if you're a genius or a troll. Or check out some of our videos, like the one on blood moons for the upcoming lunar eclipse in September. Perhaps you can plan a trip to see it. Remember, it won't be visible here in North America. What would you like us to cover next? Do you have a mystery, myth, or misconception for our next weekly video? We'd love to hear from our wonderful viewers. Thanks for tuning in to this fun episode on what the universe is made of. Join us next time on our journey through the cosmos. Catch you here at Hidden in the Stars.